So we're here with Jerry Bostick, legendary flight controller from NASA's Mission Control during the Mercury, Gemini, and Apollo eras. Jerry went on to work on the Space Shuttle and in several top positions across NASA, Grumman Aerospace Corporation, and United Space Alliance. He served as a technical advisor to the films Apollo 13, From the Earth to the Moon, and First Man, and is author of The Kid from Golden, From the Cotton Fields of Mississippi to NASA Mission Control and beyond. Mr. Jerry Bostick, it's a genuine honor to have you with us, and thanks so much for your time.
Oh, I'm happy to be here.
Well, I thought we'd start with a discussion for young learners. So as you know, the Cosmosphere camps have a number of young learners who are looking to learn more about science and space exploration. And I was curious, as they're watching this and they're developing their own habits as students at school, building effective habits are really important for students when they're coming up through school. Is there a habit that you would recommend that students do every single day?
Yes, I think that would be to plan ahead. I go to bed every night thinking about what I have to do the next day, what I want to do. I usually wake up in the morning and I make a list of the things I have to do. This is something that I started I guess when I was in high school and continued since then.
And thank you for that. When you're making that list every night before you go to bed for the next day, how do you prioritize that? Is it like a to-do list, or is it tasks or goals?
Yes, I try to prioritize it. I mean, obviously some things are more important than others, but I try to tackle the most important things first.
So start with the most important things first. It's great advice. In terms of staying motivated when you're working through that task list and also staying focused on your goals, motivation is really critical in education, and it's a problem for a number of students to stay motivated. What are some strategies that you employed during your years in school to help you stay motivated and focused?
Well, since an early age, I guess my parents had taught me that I could do anything that I wanted to do. Just believe in myself and pursue the things I wanted to do. And that would be my advice to all the young people of today. Think about what you want to do and don't let anybody tell you you can't do it, because you can. And pursue it with great vigor.
I love that. Follow what you want to do, pursue it with vigor. And so while they're pursuing that through, when students are pursuing that through their developmental years, what steps can students take to keep growing throughout school?
Well, I think just to like we were saying, keep believing in yourself. Always believe in yourself. Don't let anybody tell you you can't do something or it can't be done. If you believe in it strongly enough and you desire to do it, then I'm convinced you'll make it happen.
I love that. So building on the point of believing in yourself and making anything happen, you're one of the folks who made something happen when the stakes were really, really high in the early days of space exploration. And so in a previous conversation, you mentioned that one of the most important skills in today's world is the ability to collaborate and get along with other people. So I was curious, why is that so important in mission control, and why is it so important for the future of space exploration?
Well, it was extremely important in mission control. We all had a common goal, and we had slightly different roles in trying to achieve that goal. But we were well aware of what our roles were and what our partners' goals were, and we tried to understand each other's job, but didn't try to do it. We just did our job, and it took a lot of teamwork in order to accomplish that.
So it's really interesting when you're talking about understanding what you're responsible for and being a part of a larger team. You had mentioned also that creativity was really important when you were basically inventing the systems of mission control. So when you're working with a team of folks and you know exactly what you have to do in order to help support the mission, and you're working with folks who have other responsibilities, how can you apply creativity to solve problems and work together, especially when you were creating those systems to begin with?
Well, we had a thing we call mission rules. We sat down and for each mission ahead of time and think our way through the mission and try to think of everything that could possibly go wrong and write that down. Say, okay, this could happen, and then to write down if it did happen, what would we do about it? And then we ran simulations to test those mission rules. And it was an iteration between the mission rules and the simulations until we finally, ended up with a plan for coping with anything that would happen. And I think that's a good way to approach life. Just think about the things that could possibly go wrong to derail your project or your ambition or your goal, and figure out ahead of time, okay, if that happens, here's what I'm going to do about it. Try not to be surprised by anything that occurs.
It's really interesting not to be surprised, and thanks for bringing that up. I was curious, when you're building those mission rules, this is just to build on that note really briefly. When you were thinking of the idea of simulations and you're defining mission rules and trying to plan for what could potentially go wrong, you also mentioned earlier that there's a difference between taking a risk and being reckless. So I want to blend those two questions together. I was wondering if you could talk more about the nuances when managing risk and the differences between taking a risk and being reckless, and then how that might apply to creating some mission rules.
Well, manned spaceflight is a risky business. Anytime you put human beings on the top of a rocket and say light the fuse, that's risky business. But it's not reckless because we, the astronauts, the flight controllers, the contractors, all individually and as a team, think about, okay, what could go wrong and what could happen and what can we do ahead of time. First of all, to make sure it doesn't happen, or if it does, what our reaction should be. It's plan ahead. Think about all the things that could go wrong and try to mitigate the risk. Now, being reckless, I think, is entering into an activity where you really haven't thought about all the things that could go wrong. You just say, okay, I'm not sure what's going to happen here, but let's try it and let's see. I think that's reckless. It's a big difference in taking risks and being reckless.
I really appreciate that. And I also appreciated a couple of weeks ago when I was asking you about your favorite mission and the mission that you thought really stood out, and you immediately said Apollo 8, which I really appreciated. I wanted to ask you about Apollo 8, building on this question. Oh, sorry, were you going to say something?
No.
Oh, okay. Thought I interrupted you. When you were mentioning Apollo 8 as the mission that really stood out as the crowning achievement, and that you baked the cake before Apollo 11 put the icing on the cake, I wanted to ask about that Friday afternoon you were mentioning when Chris Kraft told you about George Lowe's plan to fly Apollo 8 to the moon, pending the success of Apollo 7. So you were given the weekend to figure out if you thought it was possible. So what was your initial reaction when you heard this task and this ask, and what did you do over those 2 days when you were recommending that it would be possible without taking undue risk?
Well, my first reaction when Chris told us about what George Lowe was thinking about was, that's crazy. And I said that. And Chris said, okay, look, that was my first reaction. And I said that to George Lowe, but that's the wrong attitude. And I want you to go away and think about it. Don't think about how impossible it is. Go away and try to think about how I could make this happen. take a positive attitude. Don't come up with all the negative things. Come up with all the positive things that we could do, you could do, that would make it happen. And so that's what I did over the weekend. It was I take that attitude of, okay, why is this not possible? Okay, what can we do to make it possible? And like you said, I was on a Friday afternoon, and we all went back on Monday morning and said, yes, it is possible. It's we won't have all the displays that we would like to have in the control center. We won't have all of the software that we would like to have, but here's how we can get around that, and it's possible.
Thank you so much for that. And during the flight of Apollo 8, when the mission was happening, there's so many different steps and milestones that you had to go through, right? From leaving Earth at the farthest point for the first time, sending astronauts through the radiation belt. Was there a specific milestone where you're like, this one's going to be really tough, and we're really gripping it tight to see how we pass through this milestone?
Well, actually, we did the translunar injection, which is the big burn maneuver that you do in Earth orbit to send the spacecraft toward the moon. That was a tense time. We were shooting for a distance of only 60 miles from the leading edge of the moon, when we arrived there. And of course, the moon wasn't there yet. Shooting for the moon, I tell people, it's like duck hunting. You don't shoot at the duck. We didn't shoot at the moon. We shot for where we thought the moon would be at the time that we arrived there in the spacecraft. And so that was a tense time, to say, okay, this is not a simulation. This is for real. We're headed for the moon, and for the first time.
It's really interesting to think of it as duck hunting, right? Versus hitting a specific target. It's a really interesting analogy. When you were putting these systems together, you were working with so many different teams and a number of different leaders. And, obviously over the decades, what you went through has become a case study for working together effectively and collaborating with people. It's an inspiration to millions of people. I was curious, with all the leaders and all the folks you worked with, who is a leader that you would have worked with where you say, that person is an ideal leader because of X, Y, Z? And what traits do they have?
Well, I had many of them.
Yeah.
Starting with Robert Gilruth, who was the director of the Manned Spacecraft Center at the time, which turned into the Johnson Space Center. But he was a leader, not a manager, and there's a difference. He led by example. He praised everybody who worked for him, when he did things right, and was and critiqued them gently when they did things that he didn't think was right. And below that was my real idols and heroes, Chris Kraft and Glenn Lunny. I can't say enough good things about either one of those gentlemen. Chris was the third person that I met when I went to NASA. And then I ended up working with him and for him for the rest of my career. And Glenn Lunny was the same way. I met him Chris introduced me to Lunny. And I knew immediately that I was in the right place and working for the right people. They were very smart people. People have said, especially of Chris, that he was unforgiving. That, he wouldn't allow you to make mistakes. Well, I'm a living example of that not being true. I made a lot of mistakes. What Chris was intolerant of was people trying to pull the wool over his eyes. I can name a number of cases and simulations, for example, where somebody would make a mistake, and then during the debriefing, they would try to talk their way out of it. They wouldn't say, "Hey, I made a mistake, and here's what I did wrong, and I'll do my best to make sure that it doesn't happen again." And I made a lot of mistakes with Chris, but I admitted them, and he came into my office one day, and I was on the telephone, and he went to my blackboard and started writing, and I said to whoever I was talking to on the phone, "Oh, I got to go. The boss is here." And he said, "No, no, no, no. Just," and he wrote on the board, "To err is human, but it's against my policy." So he was very, as I said, I'm a living example of he was tolerant of mistakes, but just admit it. You know, don't try to talk your way out of it. Don't try to pull the wool over his ass. You know. In fact,
I love that.
his philosophy of mistakes was that's how we learn. You know, we make mistakes and learn from them.
It's a brilliant philosophy. The err is human, but it's against my policy. And it was there a feeling of candor where people in that environment felt that they could, speak up and disagree? And the reason I ask is a lot of teams in the business environment today, a lot of businesses are kind of afraid to have a tough conversation for the sake of solving a problem. So people don't necessarily want to address issues openly and honesty. And there's a real issue today with candor. And I was curious, building on this very insightful point about Chris Kraft writing this on your board, "Err is human, but it's against my policy," but then separately, having folks own up to mistakes. How did you manage disagreements among teams when you had to be really rapidly candid with folks, but at the same time, maintain an air of respect and positivity like you're talking about?
Well, we were very candid, and we did have some disagreements between, for example, the systems guys who control the onboard consumables and the flight dynamics team, which I headed down in the trench. We would want to use more fuel than was available, but we understood each other's job, and we went to great lengths to try to understand where the other person was coming from, and to recognize his feelings and arguments, and then to say, "Okay, I understand. That's not what I had hoped we could do, but I understand what you're saying, and just abide by it."
It's really interesting. It sounds like there's a tone of empathy as well, about really putting yourself in someone else's shoes and understanding what their job is so that you can find some common ground.
Very much so, and we did a lot of that, and a good example is John Aaron, the ECOM, the Electrical, Environmental, and Communications Officer, systems guys. He more so than a lot of the other controllers, or some of the other controllers, understood what my job was. Enough to understand why I was arguing with him about something, or why I needed to do something. And I tried to understand what his job was. And it resulted in great teamwork. We would have disagreements, but we would understand the other person's side of the argument and abide by it.
I really appreciate that, the fact that you're putting yourself in other folks' shoes to find this common ground. And I wanted to move into a question for you about dealing with pressure and time-sensitive situations where you have to solve problems. So in today's work environment, everybody's dealing with pressure. And I was wondering if you could explain the notion of max Q, or maximum dynamic pressure, and then also your advice for professionals who are working to solve problems under pressure and how they might learn from maximum dynamic pressure during a rocket launch.
Well, max Q, or maximum dynamic pressure, was the point in the launch trajectory when the pressure on the launch vehicle structure was at its maximum due to the thrust. And so we would back down on the thrust until we got through the max Q. period. We would reduce the thrust to around 80%, as I recall, on the Saturn, until we got through that point of maximum pressure on the structure, and so that's now. I guess hopefully that explains what max Q was. But the other part of your question, is understanding, was how should managers work under pressure? Well, I don't know. Again, I think it's teamwork. It's understanding what the job you have, and what conflicts may arise. Going back to the mission rules thing, it's planning ahead, and teamwork is how you avoid the pressure, or how you get around the pressure.
I really appreciate that, the teamwork piece, and putting ourselves in the shoes of folks in mission control, where everybody's on a shared communication system as well. You're not really able to solve the problem with everybody talking at once, and that forces folks to listen, right? And maybe there's a listening piece as well for leaders and teams. I feel like a lot of people rush to try and solve problems really, really quickly, and they're like, "Oh, I've got the answer. But it's not necessarily the best answer or the right answer. And so I think that, folks could learn from you in terms of listening, and also just taking a moment to assess, to take a beat and listen. Yeah.
That was a characteristic management technique, if you will, of both craft and money. They didn't try to immediately solve a problem. They would take it step by step. They'd say, "Okay, here is the problem, but what do we have to do in order to get to the end?" And not just work on the end solution immediately. For example, on Apollo 13, it was the Glenn and immediately, and Chris, but Glenn especially, immediately realized that the first thing we needed to do was to get on a free return trajectory. And that didn't solve the problem, but it put us in a position where we could solve it later. And so, that's how we approach things. It's one step at a time, all leading up the ladder to the solution that we wanted to end up with.
I really appreciate that, taking things one step at a time and not necessarily jumping to a conclusion or thinking that their solution is the best. And, you mentioned Apollo 13, which is a case study in collaboration and problem solving, obviously. Is there an example from another one of the many missions that you worked on, Mercury, Gemini, Apollo, Skylab, Apollo, Soyuz, anything, where you and the team improvised a successful solution, maybe something that's not as well known?
Well, I guess the one that immediately comes to mind is Gemini 8, where Neil Armstrong and Dave Scott lost a thruster. Our thruster came on, and they were spinning around, and almost to the point of blacking out, until Neil figured out what the problem was. But we were in the process of doing a shift change in the control center at the time. We usually ran 8-hour shifts with an hour on each end for handover to the oncoming team. And so I was leaving, actually, with, probably 8.5 hours after it had come on. And but when we saw that, or heard about the problem that they were having on board, I and I think every other controller in the Mission Control Center stayed on because it was a continuity thing. It's not a good time to hand over to a new team when you have a problem like that. And it was, of course, Gemini 8 was, an illustration of how cool that Neil Armstrong was. I think Dave Dave Scott will still tell you today, he's not sure that he or any other astronaut could have saved that situation like Neil did. And he just did it very calmly, you know. Cool hand Neil.
Cool hand Neil,
Yeah.
was the one that made it happen.
Yeah.
I appreciate that, and I could only imagine that during a shift change as well, when that's happening, it adds a separate layer of stress that's very unique, right?
Yes.
So it's when you're handing off a situation. Speaking of the, based on the notion of like transitioning from one thing to another, you worked for so many years in NASA's mission control from the very earliest days, and then also in private industry, working for the Grumman Aerospace Corporation, United Space Alliance. So you have a really unique perspective on innovation and problem solving, and then also competition. So as companies, a big buzzword today is innovation and fail fast and have to scale real fast, and we have to go, go, go. I was curious what your advice is based on a number of these insights you've shared about, risk versus being reckless, things like that. What's your advice to companies or professionals looking to compete through faster innovation and problem solving?
Well, I guess I have to go back to the mission rule concept. Plan ahead. Try to figure out anything that could go wrong or that would interfere with your achieving your desired goal, and write down things that you should do to alleviate that, or if it does happen, how to minimize the effect it would have on your end goal. It's a good concept for life, even, I think. I even applied to taking trips, in my automobile. I think, okay, what could possibly go wrong here, and what do I want to do to, if it does happen? Have a checklist, everything I need to put in the car. To the dismay of a lot of my family, I have to admit, I think, okay, here comes the engineer, with his checklist. It's come in handy a lot of times.
I can only imagine. They're like, Dad, do we have mission rules for Christmas morning? Like,
right. Yes.
Thank you so much for your time, Jerry. We can't thank you enough. These insights are just so valuable for so many people who are going to watch these videos, read this content.
Well, it's my pleasure. And, I would like to say to the youth that may watch this is that I hope they realize how fortunate they are to be able to have a facility like Cosmosphere available to them. It's without a doubt, in my opinion, the very best space museum in the whole world. Much better than even the Air and Space Museum in Washington, D.C., because it's the only place that I've been where you get a side-by-side comparison of the history of the American space program and the Russian space program. As you walk around the circular periphery of the center, it's just wonderful. And of course, they have the two live spacecraft there that quite phenomenal also. But it's my favorite facility by far.
I love that. Well, likewise, selfishly speaking, having been really lucky to go there as a camper and work as a counselor, it's inspirational every time you walk in the door. It genuinely is. Yeah.
I'm looking forward to returning.
Likewise, I think we'll see you in October, right?
I think that sounds about right. Yeah.
Wonderful. I'm looking forward to it. And Jerry, thanks again so much for your time. Really appreciate it.
My pleasure.